Hey guys, Mr. Milton here. Today we are going to talk about solving systems of equations by using elimination. At the end of this video, you should be able to solve systems of equations by eliminating variables. Okay, the elimination method, I'll write this all out, elimination makes one of the variables in the system cancel out. Okay, so basically we're getting rid of one of the variables in the systems, and I'll show you here how we do that. Given the choice between any method, I typically will use elimination. Okay, comes natural to me, makes it feel like there's less work, but all the methods have some good things about them. Probably elimination and substitution over graphing. All right, so here we go. What we're going to look for the elimination method, what we're basically doing is we are going to try to combine. So sometimes you might see this as a combination method. We're going to try to set up our equations of our system in a way that when we combine the equations, we get rid of a variable. And just how this problem's already set up really nice for us. Hopefully you can kind of see what's going to happen. What we're going to do is we're going to, instead of trying to separate these things like we did for substitution and try to get a variable by itself, what we're going to try to do is try to make sure that we find variables that have the same number in front of them with an opposite sign. Okay, so this first example set up really easy so you can see how this is going to work out for us. So we have this system, x plus 3y equals 7, and negative x plus 4y equals negative 14. So hopefully you notice that both systems have the same variables, x and y. Okay, we couldn't solve either of them individually, but the x's, remember there's a 1 in front of here, have the same number in front with opposite signs. And this is really nice for us because what we're going to do is we're going to add these two equations together. Okay, because we know the values for x and y should be the same in both of these if we're going to find a solution. So we're going to add these two equations together. 1x minus x gives us 0x. 3y plus 4y gives us 7y. 7 plus negative 14, or 7 minus 14, is negative 7. Okay, and so from this first step you should see that what we did is we actually got rid of x. I know I wrote it down here, but I didn't want you to think it disappeared. We have 0x. What's 0x? Well, 0x is just 0. We don't need to write it really at all. And so now we're at the point where we have 7y equals negative 7. Now we should solve for y. We'll do that by dividing both sides by 7. We find that y is negative 1. Okay, now that we know that y is negative 1, we can plug that back into either equation to find out what x has to be. I'll plug it into the top equation because x is positive and it seems easier to do with a positive number. I'll have x plus 3y, but now remember y is negative 1, so I don't need to have a variable there anymore. X plus 3 times negative 1, or x minus 3, equals 7. I need to get x by itself, so I'll add 3 to both sides, and x equals 10. Okay, so x is 10, y is negative 1. Remember that we'll write our solution as an ordered pair. So 10 comma negative 1. Okay, remember it doesn't matter which order you find x and y. X is always the first point or coordinate, and y always the second. Alright, so there's our solution, 10, negative 1. Alright, we talked about, well, we want to know when does a problem lend itself to for the elimination method to be used. And we will like to use the elimination method when both equations are in are in the form ax plus by equals c, or standard form. Okay, and so basically when x and y are on the same side for both equations, we know we want to use the elimination method. Okay, so looking down here, this in mind, which systems are set up for the elimination method? Well, not this one because x and y are on different sides on both. Here we have c and d on the same side. These are both in standard form. Here we have x and y on the same side. These are both in standard form. Okay. All right, so that first example was set up pretty nice for us in the sense that we already had 1x and negative 1x. But when the coefficients of the system are not opposites, we need to multiply to make them ready to eliminate. Okay, and by ready to eliminate, we mean same number, opposite sign. So, looking at number 1, we have 3x minus 8y equals 4, and 9x minus 3y equals 5. So we see that there's no numbers that are the same, there's no variables, x and y, with the same numbers in front of them with opposite signs. We'll see we have 3x here and negative 3y here, but that doesn't help us out because they're not the same thing. We can't add them together and have them cancel out. So that doesn't matter to us. We're just looking at the x's, looking at the y's. Okay, but so now what I'm going to think is which number is going to be easier to get to be the same number by multiplication. And by looking at that, I see x is going to be the easiest ones to match up. Okay, because this is 9x and this is 3x. I can get them to be the same number if I multiply this top equation by 3. Okay, and I'm just focusing on the x. Okay, if I multiplied this top equation, it would give me 9x, which is really good, but not perfect. I don't want 9x. I want the same number with opposite signs. So I'm going to multiply by negative 3. And so now, if I multiply by negative 3, make sure I do that to the whole equation up there, I will have negative 9x plus 24y equals negative 12. And so now I'll use these as a system. And so now I can combine these, add my system together, and that will eliminate the x's. Because 9x minus 9x gives me 0, so they're gone. Negative 3y plus 24 gives me 21y. And then I have 5 minus 12, which gives me negative 7. Okay? And so 21y equals negative 7. And now I can solve for y. I'll divide both sides by 21. And y will give me negative 7 over 21, or negative 1/3. Okay, which might not be the exact number that you wanted, but now that we know that y is negative 1/3, I can plug that into this equation. I'll write that over here. Okay, y is negative 1/3. I can plug that into the second equation. So now I have 9x minus 3 times negative 1/3 equals 5. 3 times negative 1/3, or sorry, negative 3 times negative 1/3 is just 1. So I have 9x plus 1 equals 5. I will subtract 1 from both sides, so 9x equals 4. Okay, and now to get x all the way by itself, I'll divide by 9. So x equals 4/9. Alright, so not pretty numbers, but look, we're able to solve this even to these fractions, which you probably wouldn't be able to do with graphing very accurately at all. And so my solution, 4/9, comma, negative 1/3. Alright, For this next problem, let's just focus on making sure that we can set it up for elimination. We'll stop after we set it up for elimination. And you can try those as your own individual practice to solve for x and y. So for number 2, we have 5x plus 3y equals 6 and 2x minus 4y equals 5. So with our last problem, we said, oh, well, we can multiply just this top by 3 and get our x's to match up. But as we look at this problem, we have 5x and 2x, so there's not really a number that's going to be able to multiply to get to the same, like to 5. We can't multiply 2 by a regular number to get to 5. We have 3y and negative 4y. Again, we can't multiply by just a regular number to get to 4. And so what we're going to have to do is we're going to multiply both equations in this case. And because these signs are already opposites, I tend to think that we should try to eliminate the y's. Okay, now I'm going to look at these numbers 3 and 4. What can they both get up to? What numbers do they both, what's the lowest number they can both multiply to, the least common multiple? Okay, and that number is 12. So I'm going to multiply this top equation by 4 in order to get my y to be 12. And I'm going to multiply this bottom equation by 3 in order to get my y to be 12. Okay? And so we have 20x plus 12y equals 24, and 6x minus 12y equals 15. Okay, and so now we see that our y's have the same number with opposite signs. And so we can combine our equations. 26x equals 39. And then we'd be able to solve for x, plug x in, solve for y. Okay? Now, although sometimes you have to multiply, remember, it's not every single time that you'll have to multiply an equation. For number 3, as we look at the problem, we have 2x minus 3y equals 4 and negative 2x plus y equals negative 4. So we can already see here our x's have the same number, opposite signs. Same number, opposite signs. And so when we add our two equations together, 2x minus 2x gives us 0x. They're gone. Negative 3y plus y gives us 2y. Or sorry, negative 2y. 4 plus negative 4 is minus 4, 0. Okay. Quick word of caution. I know that we have some special cases, and we'll talk about it in just a second, but we have a bad habit typically, historically, of seeing this as no solution. Negative 2y equals 0. This is not no solution. Okay, when we divide by negative 2, 0 divided by negative 2 is 0. So y is 0. Okay, and then we can solve for x by plugging y into either equation. I'll just choose this bottom one. So I have negative 2x plus 0 for y equals negative 4. Put that in parentheses so you can see that I'm plugging that in for y. And so I have negative 2x, because 0 just goes away, equals negative 4. Divide by negative 2, and I find that x is positive 2. And so my solution here, remember we write our solution as an ordered pair, will be 2, 0. Okay. All right. So that's elimination in a nutshell. Flip to the back. Okay, and we'll talk about some special cases. Okay, we still have 3 possible solutions. Okay, with graphing, with substitution, with elimination, it doesn't change the possible outcomes, just different ways that we can get to it. So we still have 3 possible solutions. We have one solution. Okay, different slopes. Just kind of bringing that back. A true answer. Okay, and so keyword here is answer. And that's such as when we add these together, we get negative y equals 12, and so y will equal negative 12. When y is negative 12, x will be negative 16. All right. Okay, and so we have a true answer. Once we have a number, we find something, we can plug it in, we can find something else. In this solution, we have negative 16, negative 12. Okay, true answer. It's one solution. That's what one solution looks like. Here, we have an equation where we have infinitely many solutions. Okay, same slope, same y-intercept. Essentially the same line. Okay? And that is a true statement. Okay, true statement. Keyword here, statement, not answer. Okay? Because an answer has like something unknown equals something now a whole number. But when we add these together and try to eliminate, because they have opposite signs, same number, opposite signs, we add together, that'll give us 0x plus 0, y equals 0. So we have on one side 0 equals 0. Look, does 0 equal 0? Yes. Okay, that means no matter what number we plug in to one equation, when it works for one equation, it will work for the other. So the solution is infinitely many solutions. Okay, or we have no solution. Okay, parallel lines. Remember, that means same slope, different y-intercepts. And that is a false statement. Again, statements, not an answer, it's a false statement. So when we add these together, what we'll do, you see when we add these together, they have opposite signs, so we're ready. 0x plus 0y equals 8. And so we have 0 equals 8. Does 0 equal 8? No. 0 does not equal 8. That is false. And so, no solution. Okay? Alright, so those are the special cases, or those are the three possibilities. Some special cases there, infinitely many solutions, and no solution still happens here with elimination, because it's just a different method to solve the same types of problems that we have been going through. Okay, I want to use this time now to talk about some application problems. That'll be our next section, but I want to walk through one problem together here. So, a dock worker pays $30 for 10 pounds of seafood. It is made up of two kinds of shrimp. Large shrimp sells for $5 per pound, and popcorn shrimp sells for $1 per pound. How many pounds of each were in the mixture? And so what we're going to do is we're going to look at the two pieces of information that are talked about in this problem. And that's, once you find out how to isolate those two pieces of information, you're going to make solving these problems a little bit easier. So there are two things that they talk about in this problem. They talk about cost, money, and they talk about weight. Okay, now there are two types of shrimp: large shrimp and popcorn shrimp, and I'll just say P for popcorn shrimp. So here's our equation. We know that the weight for these equal 10 pounds. Okay, so we have so the weight of these equal 10 pounds, and so we have the weight of the popcorn shrimp plus the weight of the large shrimp equals 10 pounds. Okay, so P is going to stand for pounds of popcorn shrimp. L is going to stand for pounds of large shrimp. Okay, so the pounds of popcorn shrimp plus the pounds of large shrimp equal 10 pounds. Now the money goes like this. The popcorn shrimp sold for $1 per pound. So I'm going to say P. And just for this problem, I'll say 1P. We don't usually write the number in front of our variable, but I will in this case. Okay. The large shrimp sells for $5 per pound. So I'm going to say 5L. And I know that it costs $30. Okay. And so you see the system is just made up of the two pieces of information that they gave us organized. And now, since both of these equations are in standard form, it's set up pretty nicely to be solved using elimination. And so what I'm going to do for elimination, I'm going to find out which numbers are closest to being eliminated. Now the P's have the same number, but not the same sign. And so in order to make these the same sign, I'm just going to multiply this bottom equation by -1. I'll rewrite the system here. 1P plus 5L equals 30. Once I multiply by -1, I have -1P minus L equals -10. I'm distributing this -1 to each term. Remember, I make that determination based off of what I want to eliminate, but I have to do it to everything. And so once I do, I have 1p minus p goes away. 5l minus l gives me 4l. 30 minus 10 gives me 20. So 4l will be 20. Divide by 4. That means l will be 5. So that means I have, for this equation, p plus 5 pounds, L is 5, equals 10. And so I can find out, minus 5, that P is 5 pounds as well. I bought 5 pounds of popcorn shrimp, 5 pounds of large shrimp. I can plug that in to make sure that that cost $30. Okay, because 1 times 5 plus 5 times 5 equals 30. Yep, 5 plus 25 is 30. Okay, and so large shrimp, 5 pounds. Popcorn shrimp, 5 pounds.